Now let's do a quick run-through of using Jinx for Windows. Jinx for Windows is tightly integrated into Visual Studio 2010 and works the way you do. You don't have to change your existing development or testing methodologies in order to use Jinx. You simply use Visual Studio just like you've always done. For this quick run-through, we'll examine a simple stack object. Here we're looking at a pop method for the stack. You'll notice that the data structure is protected by a locking mechanism. If we look at the push method, we'll notice that the data structure is missing the same locking mechanism. In many cases, this omission will result in a concurrency bug, which will probably crash the application. Let's go ahead and run this application without Jinx enabled. Now this application is running fine, and it may actually run fine for days, weeks, or even months. At some point, the concurrency error that we pointed out in our code will likely manifest itself. Let's stop running this application and see what happens when we run this application with Jinx enabled. Jinx is really easy to use. It's integrated into Visual Studio 2010 as a simple tool window. To enable Jinx, you simply click on the Enable Jinx button. You can also specify how hard you want Jinx to look for bugs. When Jinx is running, it's actively running simulations to determine a thread timing that will result in a concurrency error. You can determine whether you want Jinx to look actively for those bugs or look less actively for those bugs. Finally, we'll enable Smart Stop. Smart Stop is a feature that identifies the location in your code where a concurrency error began. Now let's go ahead and run this code with Jinx enabled. You'll notice that Jinx immediately found an error in our code, and it used the Smart Stop feature to pinpoint the exact location in our code where that error occurred. If we look at our code, you'll see that Jinx is highlighted using Visual Studio 2010, the precise location in our code where that locking mechanism was missing. This is the cause of our concurrency error. In addition, Jinx works perfectly well with Visual Studio 2010. For example, if we look at the Threads window, you'll notice that Jinx has positioned the Threads window in such a manner so that we can examine our code as it stood when the bug actually occurred. The Parallel Stacks window, which is new in Visual Studio 2010, is also positioned in the correct location to help us look for errors. As you can see, Jinx is easy to use, tightly integrated into Visual Studio 2010 so it works the way you do, and it definitively finds bugs that are present in your application. With Jinx, there are no false positives. You can depend on Jinx to find bugs in your code.